This video introduces us to field methods. These are also known as survey methods. Basically, whenever we're going out in the field to collect data on the ground. This is really critical, even if you don't actually go out and collect data. I don't collect most of the data I work with, but it's really important for me to understand the issues and the problems associated with field methods so that I can interpret the data that people are giving to me. And this is even true if you're dealing with remote sense data, satellite aerial imagery. It's always good to go out and walk around the ground and see what's really there because you can see so much more of the detail that's there. And that's the issues you might be getting into in using remote and remotely sensed data. Okay, so basically the steps, don't just go out and drive off into the field and expect to have a successful field survey. First, establish the objectives. Make sure you know why you're going and what you need to collect for the task that you have at hand. Pick a site. Make sure you have permission for that site. Plan the survey, including the protocols. We'll talk a little bit more about protocols. Collect the data, then qualify the data. In other words, after you're done with it, estimate the uncertainty. Some feeling for the uncertainty. I would rather have a rough estimate of uncertainty with any data set than to have no estimate of uncertainty. So don't worry about a perfect estimate of uncertainty. It's not what we're looking for, just a rough estimate. Then we download the data, then we qualify the data again. So in other words, we qualify it when it's in the GPS, we're out in the field, and then we download it and qualify it again. Then we start doing analysis, and then you do tend to go back and get more data as needed. That's what I spent my summer doing. Okay, so common mistakes, running out of batteries, GPS breaks, is dropped overboard, lost, stolen, etc. It's one of the reasons we like the Garmin eTrexes. They're cheap, so bring 2 or 3 of them. Notes get wet, again, dropped overboard, burned, uses TP. These are all things that have actually happened with crews that I've worked with. The datum set to the wrong datum, or worse, they changed it while collecting. That's happened twice. Teams get bored, they sit around a campfire and they play with their GPSs and they change the datum, which means that the data they had that day is in a different datum than the data they're going to collect the next day, which means the entire data set is invalid. Also assuming what HDOT means. Horizontal dilution of precision comes with most GPSs. It is determined by the manufacturer what it means. It's not an industry standard. Okay, so we're collecting data. It varies with discipline. Wildlife has a huge range of different devices that they use, from little tiny ones that they put on the legs of birds to huge ones they put on elephants. Fisheries, they put them in the tags of the heads of fish. I've seen them put on sea turtles and whales. All kinds of cool stuff is going on. Forestry, anything with plants, we tend to just walk around and collect points of where the plants are. It's a little bit simpler. Rangeland, similarly. And then watershed, we do a lot of work in watershed that has a lot of variety to it, and you do tend to get wet. Okay, so what's critical? We got to find the location of whatever it is we're interested in with some degree of accuracy, right? So it doesn't have to be perfect. We've got to get it close enough. Now, if you're setting up sampling fields out in the wild somewhere, you need to be able to find it again. Driving rebar into the ground and then expecting to be able to come back in a year or two and find it is just not going to work. Lots of studies have failed to be able to find the rebar again. GPS, even an expensive one, pretty easy to find your rebar within 3 to 9 feet as long as there isn't a ton of underbrush. Then this allows us to do spatial analysis, and so we want to make sure we're getting the data to do the type of spatial analysis that's needed by the project. So with migration, that's going to be different data than density or abundance. Migration, we're looking for paths. Density, we tend to be looking for points. Habitat tends to be points, but not always. Sometimes it's polygons. The tools that we're going to use. So maps, of course, including paper maps, not just electronic. Paper has its place and is a lot easier to use and a lot less likely to get damaged and is cheaper. So definitely bring on your 24K topo maps that you can now print on the web. Have your protocol with you, your GPS, compass, rangefinder, whatever your equipment is. Measuring equipment, rulers, whatever you need if you're going to be capturing anything or measuring, say, the height of plants. ID books, do you need those? Especially if you're doing plant work, you probably need some identification books. Notebook, definitely have a notebook, pens, pencil, be able to take lots of notes. And then depending upon the discipline, you may have tags, straps, other things. Also, remember all the kind of things that you would want when you go backpacking. Even if you're just taking a day trip, you'll need food, water, somebody might get hurt. I forgot bug spray. That was painful because I didn't expect to have a bunch of mosquitoes when we were walking through the swamp this summer. And of course sunblock, and then a camera or your cell phone to take pictures. Usually we don't need high quality pictures, but we always want to take pictures to capture the site. People have died because they trusted their GPS. This is a common theme on Wikipedia and on YouTube to talk about accidents people have had because they trust their GPS. So I highly recommend carrying a USGS topo map. They're free to download, kind of a pain to print, but you can still go to a lot of stores like Adventure's Edge here in Arcata, and they have the big 24K topos for sale. So take a look at your USGS topo quad. What spatial reference do you see? What spatial reference is this map printed in? When was it printed, and does it include everything you expect? Also, what's the declination? We're going to be working with declination here in the near future. So that's the angle of the magnetic north versus the geographic north, which all our maps are aligned to. Okay, and you'll find some interesting things on those topo quads. They're really pretty cool because they have multiple spatial references on them, usually 3, geographic, UTM, and the public land survey system, which we don't use a lot in GIS unless you're a surveyor, and then you'll use it all the time. That's what the actual parcels are laid out for when people buy them or manage them. And then they can be very dated, right? The USGS topos are getting old, so they're great for some things, but they're not as good as other maps for recent changes. GPS is going to vary a lot in the cost. It's going to be between $100 and $1,000 to get 1 meter or below accuracy. A lot of the $500 GPSs have a bunch of features in them, maps you can have, all kinds of cool things, but the resolution is actually not any better than the $100 eTrex. They're still 3 to 10 meters. You really have to get up around $1,000 to get the sub-meter, even down to 1, 2, 3 centimeters. Which we're doing now with the MLID reach system. Traditional surveying has changed radically in the last 20 years because of the available electronics and the high resolution GPS and ground-based surveying networks. So it's been replaced by first total stations, and now with RTK, real-time kinematic surveying systems. That's what the professionals use. We can get close to that now with relatively inexpensive, around $1,000 equipment. Cell phone triangulation is not an option. Now your cell phone may have GPS, it may be pretty good, but the early cell phones and the less expensive cell phones are just going to triangulate off cell phone towers. That is not going to work very well, and it really only works in cities, so don't expect that to work out in the field. For GPSs, always carry spare batteries, baggies. GPS in a bag, you'll float. One without it will just sink to the bottom. Pink surveying tape, tie it to everything so you don't lose equipment. And then a spare GPS, always a good idea. These are the Garmins that we have in lab stock. However, since we're teaching this class online now, there may be a variety of GPSs in the hands of students. You're going to need to go to the owner's manual, find the quick start to get you up and running. They're going to be a little different. In the videos that I've added, I've used the Garmin eTrexes that we're going to be sending out to remote students. So just be prepared for any type of GPS. Definitely get it out. Use it around your neighborhood. Record some corners you can see in aerial imagery in ArcGIS, and get familiar with it before you head to the field. Again, there's a lot of different measuring equipment, tape measures, yardsticks, quadrats, rangefinders to lay out the area that you're within. So that's a smaller area rather than the GPS, which is for large areas. And again, these will vary based on your discipline and the goals of your survey. For the first lab, we're going to be using a pretty common one for plant surveys. It's a 1 meter square quadrat. There's also hoops, which are just round ones. We like the square ones. This one, which are not the ones we have in lab stock, but you can do this yourself. This is just PVC pipe with 4 PVC elbows. You buy this at the hardware store, put it together. You don't even need to glue it because then you can pull it apart and disassemble it. And then you can tie string every 10 centimeters. If you do this, there's 100 of these cells now, and you can just count the cells for how much each plant covers, so each species. So how many cells is covered by grass, how much by dirt, how much by this plant over here, and then that becomes the percent cover immediately. So these are very handy. They're just a little bit harder to carry around. The ones in lab stock you'll need to assemble. They're easier to fold up. Again, notebooks, computers are going to replace notebooks when you can fold them up, put it in your back pocket. It costs 5 cents, and you can use it to start a fire or TP. Paper is really, really versatile. Okay, so get your notebook, keep it with you all the time. Remember to keep a pencil with you as well. It's still fragile, so best to toss it in a baggie or a waterproof backpack, somewhere to keep it safe.